Any questions?
Are we moving on to chapter 8 or did we start chapter 8 Wednesday?
Sorry?
Are we moving on to chapter 8 or did we start chapter 8 Wednesday?
We've not started chapter 8. I'm gonna wrap up some stuff from chapter 7 and then we'll do 8. But the test is 2 through 5. And the test is the only thing that we're doing on Wednesday. So when you're done with the test, you can go.
That'll be chapters 1 through 5?
2 through 5.
2 through 5, okay.
1 is just there for your enjoyment.
Oh, like introduction, gotcha.
Yeah. Also, the lab that we did last Wednesday, is that Atwood's machine? I think. Generally, labs are due in a week, but if you've got the test, if the lab's not ready tomorrow, then just get it to me later in the week, because the test is a higher priority than that one lab. Or if it's ready, hand it in. All right, so we have the 3 work energy relationships. Not with that marker. Yeah. We have the total work. It's equal to the change in kinetic energy. The non-conservative work equal to the change in energy. And the conservative work equal to the negative change in potential energy. And the formula for kinetic energy is? Let's try that one again. What is the formula for kinetic energy?
1/2 of mass times velocity squared.
Close. It is a scalar.
Is it half mass 1 plus mass 2
Okay.
times velocity squared minus 0?
Oh, you're doing it specifically for the lab. It's not velocity. Sorry about that. Let's try that again. What's the formula for kinetic energy? I believe we went through this, the one formula at that. I expect you to know.
Oh, it's like 1/2 mv squared.
Yeah, there we go. Wow, so in unison, it's like a single voice. The issue I had with what Grace said is that V stands for speed, not velocity there.
Yeah.
No, he said there was still 12 of us.
Yeah. I'm not quite sure where everyone is. But they are adults and they get to make that decision. All right, so what's the formula for potential energy? All right, the question on the floor, Caitlin, is what is the formula for potential energy? I'm gonna go ahead.
Oh, wait,
Yep.
potential energy formula, like, isn't there, which one?
Yeah, there we go. That's the proper response. What is the formula for potential energy, gravitational potential energy, if little g is relatively constant?
9.8. Okay.
I was trying to remember actually if we did that. I didn't see notes from,
I don't know. I just had,
so I got to the 1/2 mv squared. And then we just did, all right, so we haven't gotten to that one yet. All right. All right, so every conservative force has a potential energy formula. So the conservative force, called weight, although any place where little g is relatively constant. And the acceleration due to gravity is relatively constant. You have to, if you get up to the edges of outer space, it's like 9.2 meters per second squared. So and that's 100 kilometers up. So anything that we would deal with, even unless you become an astronaut, it's gonna be relatively constant for Earth problems. The formula mgh. If you recall that work is force times a displacement, well, there's the force and there's the displacement. So if I've got the ground here, and I've got my, let's say, initial height, final height. If an object falls that distance, so let's say I take a rock or some object, I start it here and I drop it, it will of course gain speed, which means the kinetic energy goes up, which means potential energy goes down, because gravitational force, weight specifically in this case, is a conservative force, so energy is conserved. So if I've got so I have some mass here, I know that the conservative work is equal to, let's do it where I've got more room. The conservative work is equal to the negative change in potential energy. I know this is force times displacement, which would be the negative, whatever that formula is, final minus initial. The force is mg, and my displacement is, well, my displacement is in the same direction as the force. They're both in the same direction, so my dot product here is going to be positive. So in order to get a positive value here, that's going to be hi minus h final, because hi is bigger than h final, which is distributing the negative sign. I end up with ui minus uf. So this is the essence of the derivation of it. And again, not doing this to regurgitate it for you to regurgitate it later, but doing it so that you see that it comes from somewhere. And also one other point, which is about to pop up. So whatever formula I have for u has to satisfy this. And so you look at it and you go, well, U is just MGH, well, that works. I got my initial minus my final value, I got my initial minus my final value. That makes sense if I just let U equal MGH, it works. But there's another formula, matter of fact, there's an infinite number of formulas, but there's another formula that also works. I can let U equal something else that will give me the exact same problem, this exact same relationship.
That like that we know,
Pardon?
like a formula that we know.
You can, if I just told it to you, you would go, okay, yeah, that makes sense. I was hoping someone would talk about what other formula U could be so that this works.
Would it be weight times height?
You said length, weight times height? I think I would consider that in the category of the same thing.
Is something to do with like displacement or something?
I could connect it.
And it like does have to do with position, right?
What's the relationship between position and displacement?
Position is starting from 0 and displacement is us from like where it started.
Yeah, okay, I'll agree with that. So what's gonna be the difference between the displacement of an object, this is overall displacement, of course, displacement of an object and position?
The starting point.
Okay. Yeah, this could evolve into a read my mind exercise. Whatever the starting point is. In other words, there's just some constant. So I could add 2 to this, it still works. Because this one becomes MGH initial plus 2 minus MGH final plus 2. The 2's will cancel out because I got the negative here. So whatever, I can throw any constant at the end, it still works. So officially, the formula for potential energy really is MGH plus a constant. Now, usually make the constant someplace convenient, or some convenient number so that it makes the math a little bit easier. It doesn't have to be. Students, especially starting out, tend to make the constant in not the simplest place. For example, I take my mass at, we'll just say that, and that's my ground. We'll make that 30 meters. And I want to know how fast it's going when it's 10 meters above the ground. So I take it, I drop it. So my initial velocity, 0. Or my initial speed, more specifically, 0 meters per second. All right, here's the thought process. As it's falling, what are the forces acting on it?
Force due to gravity.
Is that conservative or non-conservative?
Conservative.
Therefore, energy is conserved. Since energy is conserved, whatever energy I have here equals the energy I have here. They are equal. What are the 2 types of energy?
Potential.
Kinetic and potential.
There we go. Same is true over here. K final plus U final. Formula for kinetic energy?
Half mass, half mv squared.
There we go. That's 1/2 mv initial squared. Formula for potential energy when the force is weight.
MGH plus like a constant.
Plus some constant. And then same thing here, except let's say final on it. plus mgh final plus that same constant. Let's see what we can get rid of. Is any of the stuff equal to 0? Think step by step. Is this equal to 0?
No,
Why not?
because the ball has a mass
Okay.
and it will have a velocity.
Or speed?
Yeah.
Does it have a speed initially?
No.
So this is 0. We're talking just at the very
Oh,
top.
never mind.
Is this equal to 0? Is M, G, or H initial, any of it 0? I got a couple people shaking their heads no. All right. The constant we'll worry about later. Is this equal to 0? So it's stopped when it gets to here? It's up to people nod yes. All right, Savannah, you're saying no.
If it starts at 0, wouldn't the velocity be negative? Or no?
No.
Okay.
If what starts at 0, if the,
Or if it like ends at 0, if the velocity was doing something, wouldn't it be negative or no? Or would that be?
no, well, I think we'll address that. When we get to, some freedom that we have here, ask it again if it's not answered. I think we're getting to it though. All right, so the question is, when the rock is falling, our object is falling, when it gets to here, it's gonna hit the ground, but we're not worried about that. We stop the problem before it hits the ground. Is it stopped here?
No.
All right, so that can't be 0. It has a mass, it has a speed. All right, mg, H, well, we established there's mass. We'll put this on Earth. There's acceleration due to gravity. H final, is that 0?
No.
No, okay, that's fine. And constant we'll worry about in a moment. All right, so what we have here, since energy is conserved, that's the one I want. I have my initial energy equals my final energy. I have initial kinetic plus initial potential equals final kinetic plus final potential. And it helps if I put the right letters down. And then we just take one step further, 1/2 mv initial squared. I'm just rewriting what I have over there, just slightly different format. Each initial plus some constant equals 1/2 mv final squared plus mgh final plus some constant. And now we get rid of stuff. I got kinetic plus potential equals kinetic plus potential. We've established that's 0 because my initial speed is 0. The constant is going to cancel out with the whatever that constant is. I usually don't write it. Textbooks usually don't write it, but then I'm left with this. Notice that I have mass in every single term.
Which means you could divide.
So the shortcut is I could divide the mass out. But if that bothers you, make up a mass. If I don't give the mass to you, make it up. I would recommend making it up something convenient, like 1 kilogram. But the mass doesn't matter, which we've established. If I drop 2 objects, different masses, they'll fall at the same rate. So I've boiled this down to the acceleration due to gravity times the initial height is equal to 1/2 times my final speed squared plus the acceleration due to gravity times my final height. So now, let's plug numbers in. G,
9.8.
okay? The initial height,
30.
equals 1/2 final speed plus 9.8 meters per second squared. And final height,
10 meters.
if I multiply some stuff, I got 30 times 9.8, which is 29.4. So 29.4 equals 1/2 V final squared plus 90. That's not right, that's 294. That is still not right. That is, oh, because that's wrong, that's 98. There we go. Now let's get rid of that. There's the math problem. We're trying to get to V, so we gotta get rid of all the other fluff around it. So first, let's get rid of the 98, so we get rid of it by doing the opposite. 294 minus 98 is 196, is equal to 1/2 VF squared.
And then you can multiply 196 by 2, right?
Yep, get rid of that half by multiplying by 2. So 392 is equal to VF squared.
Square root 96.
And get rid of the square root by undoing that one. And so VF is whatever the square root of 392 is. If someone would be kind enough to do that. Point something.
19.7989.
7989 units.
Meters per second.
All right. So, a little over 40 miles an hour.